Good morning, everyone. Let us continue the term pressure in the chapter of force and pressure. In the last video, also, we were discussing something about the pressure. That pressure is force applied per unit area. Since force is involved in all the daily life activities, the pressure is also involved. Because wherever the force is applied, definitely pressure is developed. Then its SI unit is Newton upon meter square, but specially for the pressure, a unit is given in the name of scientist, that is Pascal. So we defined 1 Pascal also. When do we say the pressure applied, the pressure developed on a surface is said to be 1 Pascal when 1 Newton force is applied on 1 meter square area. Suppose we have this is the area of surface. On this area, how much force is applied? How much force is applied? If 1 Newton force is applied and if the area is 1 meter square, then the pressure developed on this surface is said to be 1 Pascal. Then in the formula also, P equal to F upon A. That means pressure applied depends on these two factors: force applied and the area on which the force is applied. Then coming to the relation between them, this is just mathematical. In any fraction, if we take denominator constant, A is constant. If A is constant, definitely P directly proportional to force. Directly proportional means if force is increased, pressure also increases. By keeping the area constant, if force applied is increased, then the pressure developed also increases. So we say the pressure is directly proportional to force. Then if F is constant, in that case, P is inversely proportional to area. It means the same force is applied on different area, then the pressure is also different. If we increase the area, pressure decreases. That is the inversely proportional. If one quantity increases, another quantity decreases. If this quantity decreases, this quantity will increase. And this relation is having many examples in our daily life activity. By taking this relation, that is pressure developed is inversely proportional to surface area. There are so many examples and the application also. This example is also having many applications in our daily life activities. Let us see that examples and then we will go to that numerical part. How we calculate the numerical part. Now we'll see the many examples that for this case pressure is inversely proportional to area. That is, if we increase the area, pressure is decreasing. Decrease the area, pressure increases. For this, I take the first example. You are having the bags. Let us take the example of school bags. On the school bags, you have the straps which are putting on the shoulder, and you see that the straps are wider now, and in that straps more cushions are given. That wider straps and cushions are provided in the bag to reduce the pressure developed on your shoulder. It is because when area is increased, because you are putting number of books, which increases the weight of object, weight of the bag. Here one thing you must know, that the weight of object, weight of anything is also equal to force, because I am standing on the ground. Whatever be the weight of my body, that weight of body apply force on the ground. So the force applied by me on the ground, that is equal to weight of my object, weight of my body. So weight. When we put the books in the bag, the weight increases. So that bag apply force on the shoulder. But the force applied by shoulder on the bag is the effect of force applied by the bag on the shoulder is not same in all the cases. In your bags, the straps are wider, area increases. For that weight, when we increase the area, definitely the pressure decreases, so we feel comfortable. Instead of that, wider straps, if we remove that wider straps and fix two thin strings, two thin rope like structure, thin, instead of that wider straps, the rope like structure, this is your wider straps. Instead of replace that wider straps by using the thin string or thin rope like structure. Then put the same amount of book weights in that bag. Now put that bag in your on your shoulder and try to walk for some distance. Then you will find some pressure is applied on your shoulder. In the two cases, with the wider straps, the pressure developed on your shoulder. In the thin rope, the pressure developed on your shoulder are not same. In the thin rope case, you will feel more uncomfortable than the wider strap, and you can see that some swelling is developed on the shoulder also. You feel more pain on the shoulder in the case of thin. It is because when the area is increased, the area is decreased, the pressure is increased more, we feel uncomfortable, we feel pain. So that's why in the school bags, wider straps are provided. This is one example. Then coming for the second example, suppose if you take the knife, when we purchase the knife, the new knife is having the edge. As the knife is used for longer time, the edge is changed. How it changes? In the new knife, the edge is very very thin, the knife is very very sharper. As it is used for the longer time, the knife become blunt because the area of the edge is increased. Then cut the two knives. One is with the new one, another one is older. The new knife is having the sharper edge and you can cut the vegetable easily. If you use the older one having the area greater, that is the blunt knife, then if you try to cut the vegetable, even the tomato also cut with that, then you need to apply more force. Why is it so? It is because the new knife is having the less area on its edge, so the pressure is more. more pressure developed on the surface of the vegetable and it cut easily. When the older one is used, it has the wider area on the edge. In that case, the area increased, pressure is decreased. So less pressure is developed on the vegetable, so we are not able to cut easily. So that's why the sharp knife cut vegetable easily than the blunt knife. Then in another example, the camels are preferred while crossing the deserts because the camels are having wider feet. With that wider feet, the area increased and it experienced less pressure so that it can walk easily. But if we people are trying to walk on the desert area, in that case, we will not be able to walk over the longer distance. It is because the area of our foot is very small. For our weight, we are not able to walk easily. So that is also one more example. Like this, we can see many examples for this. We'll see the numerical part in the next session.